Okay, so we continue the newspeak subject, and well, this time it's about the UI. And if you were a little overloaded with information in the last talk, well, this time you will actually see some code that works, and you'll see that in fact this is much more familiar than it may have seemed. So, well, as many of you know, I used to work for Cincom and was the tools guy for VisualWorks, and many people now ask me, well, how I am, and so this talk is also an answer to that question, more elaborate than just saying, well, I had a fabulous time last year, which is true. So I'll start to warm up with a demo. And everyone is sleepy after lunch, as I have been warned. In this demo, we have the newsfeed image, which is based on this quick 3.9 image. And well, it's running on our VM, and it has a number of things that are not present in this quick image. I hope the font is large enough to be readable. So, well, first of all, I do something magical that I'm not going to explain because it would take half of this talk. But well, it basically reconfigures the event handling in the VM to be compatible with what we're trying to do. And then I put this expression, which opens something that looks like, well, the standard 5-lane browser, and well, you can see that it's showing the system code. You see class categories, classes, all that stuff. Now, to take a look at this code, what I'm creating here is an instance of something called Brazil Classic Browser. So this is just some example application, and I'm grabbing a window from it, and then I'm doing a number of steps that are not that important, other than you can see that I'm holding on to two important objects. One of them is called Morphic Desktop, and the other is Windows Desktop. And well, now I'm going to evaluate the expression that grabs the window and removes it from the Morphic Desktop and places it on the Windows Desktop. And well, here you see that the window has become a window that looks like a Windows window. And in fact, it is a Windows window. I can move it outside this quick window, and it's still there. And it's not just a GIF. I mean, it is interactive. I can scroll. I can do all the interactions. The widgets in the windows are standard widgets, these boxes. And you can see that even the state of the window was preserved. So the selections that I made while in Morphic are still here in Windows. And while I can select more and I can play with this window, let's resize it a little and move it down here. And now I'll go back to Morphic and the next pair of expressions, which does the reverse. So I remove the window from the Windows desktop and place it back onto the Morphic desktop. And here it appears back in Morphic in the same place and with all the same selections that were there. And it is a Morphic window. I can click on it with the middle button, and well, you can see the halos pop up, and these really are morphs. I can, for example, I will not spend time on that, but well, I could rotate things and everything. I cannot in Windows, it's a loss, but we'll have to do with it. So this was to illustrate one important component of the newspeak UI, which I'm not going to talk about today. And the component is called Brazil, and it's named so after the movie, which we all like so much because well, it talks about many things, and there are many references that could be easily applied to software development. So Brazil is the widget framework. And it is an abstract widget framework, which means that well, it does not actually implement any widgets. So you create your UIs composing them of these abstract entities, sort of logical widgets. And then it maps them onto one of the native UI libraries that it supports. And Morphic is just one of the native libraries from the point of view of Brazil. And this is why that window was able to go between Morphic and Windows, because, well, there really is no difference between the two. But, well, we're not going to talk about Brazil here, we're going to talk about Hopscotch. And Hopscotch is both the application framework and the development environment. And I refer to both by the same name because they were developed at the same time with the needed tools, and I will speak shortly of why we needed new tools in order to work with NewSpeak code, and so there came both the framework and the IDE. So why did we need new tools? Well, we just looked at something that looked like the regular Smalltalk browser in that demo, and well, here's the real Smalltalk browser from Squid. And well, it's a very familiar design. It has been around for 32 years if we count it from 76, which is when they say something similar to this browser was first created at Park. And it hasn't changed much, even in the RP. It's pretty much the same stuff. Well, we have these 4 list boxes up on top, and well, we view details at the bottom. And the reason this is so is because the hierarchy or the structure of executable objects in Smalltalk is 4 levels deep. So we have categories, classes, protocols, and methods. And at each of the levels of the hierarchy, we have things of the same kind. So this is in fact no longer true in VisualWorks. Well, this was true in Smalltalk 8. And this is why it works so well in this scheme, because, well, naturally you map 4 layers to those 4 list boxes. Each list box shows things of the same kind, and it's easy to program, and it's kind of a fairly obvious design. Well, if we move to NewSpeak, there are a number of changes, and the most important is that classes nest. And because they nest, it means that the hierarchy can be, at least in principle, arbitrarily deep. And then also horizontally, inside each class we have entities of different things. We can have other classes, we can have methods, we can have slots. Well, methods can be organized into categories or tagged, or will have some sort of classification structure to them. So it becomes much more involved. And if we try to map something like this onto the classic UI architecture that we had before, well, we need something like this. For an arbitrarily deep hierarchy, we need an arbitrarily wide browser. And well, obviously this is a suboptimal solution. Well, Apple has done something like that. With the Finder, you have columns, and well, you can scroll. IBM has done Trailblazer, and well, that idea could also be adapted. But there are other issues with this kind of design, and well, one of the most important limitations of this that well, hasn't really been resolved in all these years is that this is highly modal. As soon as you start changing a method, you are in a mode. You have to finish changing this method. You look this up in this little room, and you don't go out until you are done. And while you are editing a method is in fact exactly the time when you might want to go and research something you want to look at. Something you call, or you want to look how to create an instance of a class that you want to create. So you need that information, but you are locked and you don't leave that state. And so all this is to say that there were a number of reasons why we wanted to try a different approach. And the different approach I'm going to demonstrate. Now I will switch to this screen. Get rid of this guy. So the different approach is the Hopscotch browser. And well, you've seen it in the last talk. And this is it again, but this is in its initial state. You see that it deliberately so, it looks very much like a web browser. You see the familiar navigation up on top. There are back and forward buttons here, and there is a refresh button, and something that looks like a search box by its location, and the button next to it, and it is in fact a search widget. And this starting page, well, it's composed of links. All of these things are links that lead somewhere. And up on top, we'll have links to the place where we can look at the system source, and where we can do source control. And but a very convenient element here is this list of recently visited entities. So most often we don't even need all of that. We typically work in a small, well, each of us works in a small number of packages and works with a small number of classes. And they're all listed here, and you can see that I work with Brazil and Hopscotch. among the categories, one of them is called STS demo, and this is the category that is created specifically for this demo. So we will go there, and it already has a class called STS 2008 demo, and the icon of this class tells me, at least because I know these icons, that it's a newspeak class. But just to warm up, we will create a couple of, we will create one Smalltalk class, just to not, so that there's not much of a change all of a sudden. So to create a class, I clicked on this plus button, and it gave me a template for this class. And it has a definition template, and we'll fill it, we'll say we want a subclass of a collection, and we'll call it food collection. And, the important point here is that while I am filling out this template, I'm not in the mode. I can go out, I can go back to the home page, and then I can return, and well, I'm still there, and my work is still there, and so perhaps I could have gone someplace else and looked up some classes, decided if the name is appropriate or whatever. And finally, when I'm back, I'm clicking on the accept, and this is when the class is created, and what you see, it has a different icon that tells me that this is a Smalltalk class. And it is an abstract class, so it has this icon here. And there are also numbers on the right, which don't tell much in this case, because all of these are fairly basic classes, but they show the number of subclasses and the number of methods in a class. Well, let me show you something more interesting. Oh, here are the abstract classes of Brazil. And you can see on the right here that, well, here we have a class with a large number of subclasses and a large number of methods. And this is the visual. And visual is sort of like a visual part, visual component in visual works. It's the root of the hierarchy, so obviously it has a lot of stuff. So we'll go back to the demo category. So if we go inside the collection class, well, you have seen this presentation already. Well, this is in fact a Smalltalk class. Hopscotch supports both Smalltalk and newspeak. And for a Smalltalk class, well, we see some sort of a structured presentation. We see the name. We can rename it simply by clicking this control next to it and typing the name, and the category that is contained in, and the category name is a link. So if we ended up on this class by some other means of navigation, we could have gone one level up to the category using it. And we have links to the superclasses, and we can also have a look at the plain textual definition of the class. And well, we don't have any methods because it's a new class, but you see that we have three ghost methods, which are, well, they're not methods, they are just some elements there to show that, well, there are some subclass responsibilities in this class that are not implemented. And if I expand any of them, I see the definition of the method that declared the subclass responsibility. So here I can, let's implement this add method. Let's say this way, it's not very useful, but it will do. And now this is a real method. So if I collapse it, even if I collapse it, I see that it is a real method. And it shows me, well, also right here that the method has 891 senders, which isn't probably a very useful information. But if we go to another class, well, let's say I just jumped to the collection class, and well, in the background it populates, it looks at that information and populates this list. I can see that, for example, the method choose1 has no senders. Anything else? Capacity has no senders, so immediately there is some information that is there that well, can make us think, well, we need these methods. So all of this was to illustrate kind of the general theme of the environment without regards to any particular language. So there is a lot of information that is brought together, and it's all more or less you can hop from one place to another, and it combines within one window different ways of presenting different structures of data. So for example, right now we look at the class. Well, you can see next to the add method there is an icon that tells me that there's a superclass definition of a method by the same name. I can click on this and I see what is traditionally called the inheritance view of this method. So I see its definition in collection and my own definition highlighted in my collection class. Well, this in traditional architectures, this requires separate tools. I don't want to include those. But once we get out of this mode of thinking that a tool is something, is a window that has a certain structure that we hard-coded using a GUI builder, and instead we just start composing these things as essentially interactive documents and show them in a single viewer, we have much more freedom in how we can express these objects. Essentially, the task of designing tools becomes a task of deciding, well, what does this object look like? How do I want to show it? And you have complete freedom of deciding that. So for the next part, we're actually going to build a new tool. And to build a new tool, we will go into Newspeak, and we will do it in Newspeak. And so I went into this demo class, and as you see, the comment says this is the module for Smalltalk Solutions. So this is a top-level class. It's not nested in anything, as it says here. And if you, as you remember from the last talk, that means, well, typically we use these things as modules. So they are something that holds other pieces of related functionality together. And I already have some content here, so I have some slots that I put for convenience. And I switch to the definition view. You can see that I am importing 3 names from Hopscotch. Well, I'm not going to explain what they are. Well, one interesting point perhaps is that I am importing something that is called hpresenter in Hopscotch, but I'm importing it as presenter. So of course, when you import, you can rename and you can import things as in whichever way you like. For example, if you want in your code to refer to ordered collection as list, or of course, just bind it to a slot that is named list and do that. So I have 2 classes here. They're called file and folder, and I'm going to use it for this demo because files and folders, they're interesting in that they form a hierarchy that is somehow similar to the to many object hierarchies. We can have an arbitrary number of folders nested inside each other, and the folder can contain other folders or files, so they're heterogeneous. And so this is an interesting example, and I have 2 classes for implementing files and folders. I'll expand them in place, so that's not a thing I think you saw it in the last demo. So for navigation, when I see these classes, I can either dive into a class and then I see that class alone in the window, or I can expand them in place, and that works in a number of places and categories as well. And then I have this sort of like a single code listing kind of view of these classes. And so when we have a file, and the file, to show you the definition, well, this says that, well, we define the file, we create an instance of this file by sending the name message to file, and we'll have a slot where we remember the name, and the folder is a subclass of file. So here, this line defines it as a subclass of file, and so what we do here is we pass the name onto the initializer of the file class, and we remember the contents. So contents is something new that the folder has that the file doesn't. I'm going to add a couple of methods to file. Well, actually, no, I'll do it later. So for now, we're done with classes. So we're going to create the actual UI that will show these files and folders. Well, before then, let me also illustrate how we're going to work with this module. Well, Gilad mentioned it that, well, down the road there will be these object literals that sort of bootstrap the system, and for now we just use workspaces and we use Smalltalk syntax. So here in this line, which I'm going to evaluate, I create an instance of this module. I give it a platform to extract whatever it needs to extract, and I save it as a variable named demo. And so this demo is now an instance of this module, this newspeak class. And for example, I can send to it a message file, and I can see that what I get back is a file. You see, it's something that has a superclass and well, other stuff, or some stuff you will not find in Smalltalk classes. And I can also send to it the message example directory string. You can see that there's a method here in this class called example directory tree, which simply builds a folder tree with some interesting structure that we're going to look at. So I can send this message to this module, and here is our tree. We have the root name / and we can expand it, and here's a folder name etc. and so on. But we're going to build an application that shows this in a somewhat nicer format. And to do that, we're going to add 2 new classes to this module. One will be called file subject, and this isn't a tutorial on Hopscotch, and so I'm not going to discuss at length what subjects are, what the vendors are, what are the differences, but I'll just take my word for it that we're creating both. Briefly, presenters are essentially the applications, and subjects are, you can think of them as specifications for those applications, or sort of like a URL. So a subject represents a particular way of looking at a particular object. So we created the file subject, and we are creating a file event. So we have these 2 new classes. And in file subject, I'm going to add a few methods that we're going to need. One of the methods is create presenter. This is what ties these 2 things together. Well, you can see that even though in the Smalltalk class that I created, there were ghost methods that indicated to us subclass responsibilities that were not provided. Well, here there was no ghost method, and this is because there is no support for it yet, as Gilad said, because newspeak is more dynamic and things are much later bound. When we look at this new class, we cannot in fact say what is the superclass of this class. It will be decided later, it will be bound later at one time. So at this time, we don't know much about this class. And there are ways around it. We can come up with heuristics that will work in 95% cases. But well, it's just not there yet. And also because it will create some good karma, we will add the equals method. And it's not a very good definition of an equals method, so I'm going to collapse it so that you can see it. And when we create an equals, we also create hash. And Andreas will tell us all about creating hash methods sometime later. So now the subject is ready, and I'm not going to come back to it anymore. Well, we're going to work with the presenter, because presenter is the application. And one part that the presenter necessarily should have is a method called definition. And this is what defines what the presenter looks visually in the window. And just to start, we'll say that we want to show it as a label that will show the file. And well, we don't have the method named file, of course. So we'll also define this. And notice that right now I'm working on 2 methods at the same time. I'm creating 2 methods. So again, nothing of this is modal. I can go elsewhere, and then I can, for example, I can open the history, and in the history, this is even marked with as something that has been saved. Jump back. So the file is available, we'll retrieve it from the subject as the model. And so now we can save this definition. So you can see that the label message sent, because this is a message sent, as you saw in the previous talk, is highlighted as a potential error, but well, it actually is not. Again, this is an issue of getting that information, and sometime later, when we have some live objects in the system, this will actually start working, and we will see those as they are. So this is the minimum that we need to actually open a presenter. And here I relate an expression in the workspace, and I get the presenter. So now we have a new Hopscotch window, and here's our presenter. We're looking at this /file, /folder. And well, this isn't very exciting, and there's a mouthful in the title bar that tells us what we're looking at. So well, let's first of all fix the title bar. So we'll add another method to the presenter called title, and we'll say that, let's say we want to say viewing. So if we go here, refresh, so now we know the title is fixed. So I'll collapse these, we will not do that anymore. So the definition is a regular method. It's executed as a method, and its function is defining how the presenter, what the presenter looks like. And the appearance is composed of little bits and pieces using this syntax that, as we move along, you will see is essentially a domain-specific language. So, for example, let's make it a little more exciting, and instead of just showing one label, we will combine two labels together. So we'll say that we want to have a row that will consist of a label that says name column, and then there will be the other label that we currently have. So we change this definition, and we reload the presenter, and so now we have these two labels arranged one after another. So again, row is a message sent to itself, and it's a combinator. So it takes two smaller pieces and combines them together to form this new visual appearance of our presenter. And in fact, you can see that the red is gone now, and it's all highlighted as valid messages. And this is because now we have some live objects in the system that we can look at, and we can figure out who is in fact the superclass of this guy, and therefore we know what messages are going to stand. So before moving on, I'll refactor things a little. So let's save this as a mental name head. And in the definition, so the next step, of course, well, we want to actually show not only the thing that we're looking at, but also the content of that thing. So in order to do that, we will replace the definition. We will say that we want to have a column, and the column will include the heading, which we just defined, so we need that definition elsewhere so that it reads nicer. And it will be followed by contents examples. Yes?
Vassili, you might put out with the brackets, with the braces on there. That's just array width.
Yeah. So the braces, the Spook programmers know that they create an array. They're an array constructor. In VisualWorks, it's not available, or there is an add-on package that I implemented some time ago that does the same. But yeah, essentially, when you put a number of expressions in between the braces, it's the same as saying array with some number of tags. So it evaluates all of those expressions, and then constants up an array, and puts it there. And so you end up with an array. But this works very nicely in a syntax like that, because it looks, well, essentially, like a domain-specific language. But yeah, what we do here is we take an array, and then we concatenate it with some other stuff. And so altogether, we will get a column with a bunch of stuff in it. So we want to define these contents presenters, and I'll just copy and paste. I have this cheat sheet, and to make things go faster, so I'm just going to copy and paste the definition. So to create the presenters for the contents, we go over the contents of the file, and we collect the presenters. Yes?
Why is your definition window still highlighted on the right there?
It's because it's in the process of being edited. So whenever you start modifying a method,
Means it's dirty.
Oh, okay.
Yeah, means
Okay,
it's
I thought
dirty.
you were done with it.
Yeah, no, I'm not done with it. Well, I can say, yeah, I'm done with it. We need to define this file presenter on, which will create the actual presenter on the file. And just to start, we'll create something very simple. We'll just create a subject on a file, and we'll ask the presenter the system that one does. And so now this is complete. And if we refresh now, we will get a walkback. We get a walkback because our file does not understand contents and walk obviously. So we have two things: we have files and we have folders. On the folders have contents. Files don't. So in fact, we want to go back to files and add a method called contents. And in this method, we'll just answer and enter array. And if we refresh now, well, we get a lot of stuff, and in fact, more than we expected, because what it did now is essentially it did this tree walk-in, and it created presenters for all of the things and it displayed it as a column, which is informative, but we would like to have this more like a tree. So in order to do that, when we create a presenter for a file, I'm going to collapse it all and we'll just we'll use another combination, another way of combining these bits of interfaces, which creates a toggle, which is a column. So we'll say that we want something that will have as a heading, it will show a label with a file name. So we want a file. And as the details, it will show the presenter on that file. So we save this, and now when we look at this, you can see that, well, now we see only the immediate contents of this thing. We see the name, but we can expand that. We can see costs. So, well, this was one example of composing different presenters. To make it a little more interesting, well, let's include something else entirely in our definition. So here in the heading, in the definition here, so we'll start with the heading. So let's add an inspector that we can view this object there. So some code. So here again you see the already familiar heading details statement, and this tells that we want to have a label called inspect, and it will expand into, well, transform that into an inspector on this object. Except you can see that color is highlighted because, well, in fact, color is a class in the system, but it is not visible because we're in newspeak, and this is a sandbox. And we didn't make any arrangements to have color available to us, and this is why it is an unknown class. So we have, in order to be able to use color, we have to go to the module and say that we want to get color from the platform, from graphics, from color. It's called color. Right. And now we can go back here, and we can accept this. And because this is a work in progress, in fact, we now have to reboot, even though it's bad. But we have to throw away the old module and create a new one, because the old one doesn't have the color bound. We changed the definition, but the color slot in the old module is not bound correctly. So we throw this away. We open a new one, and you can see that inspect is there, and it expands into a Hopscotch inspector. Hopscotch inspector, well, it just shows the header for the instance, and it has a link to the class. So from here we can go and browse the class, and it shows the instance variables. And, well, we can expand these guys and we can drill down, and we can also interact with them. So for example, here I can click interact, and I can type, it's like an embedded workspace. I can type self-main reverse. And this gives me the result, and the result is embedded right in the same UI. So it's just another thing that you can expand to look at that result. And then when you don't need that interaction anymore, there's click discard.
That was not Newspeak or Smalltalk?
Well, it's all together because they're compatible. They are objects that send messages to each other. So you can communicate between the two.
No, the syntax for the
that was Newspeak. So yeah, and I can collapse it and it all goes. And well, as another enhancement, in fact, we can get rid of that other window because we have a browser, right? So we can have our application and our browsers all together here. So from here, I'll just go and I'll find our file presenter here. And as another expanded step of the example, let's also inspect the presenter itself. So let's just copy this definition and change the label to inspect me. And here, instead of inspecting the file, we'll inspect self. And now let's go back to this guy and look at this new form. And now we can inspect this presenter and the thing that it presents. And to take it even further, let's go here and also add a browser for the measure. So to do that, this code, I'll say here, browse me, and the thing that it expands to, you just take my word for it. Basically, imagine that this makes sense. Because what it does is it creates a browser the proper way, going through the reflection that will create mirrors, and so you have to do it properly. And so this is the way that it's done. And it also shows us that we need the reflection object to actually get the mirrors from. And for that, I will add another method here, which well, the interesting part of it is that it communicates within the hierarchy. So these presenters inside the browser, they can communicate with the with presenters and the window that contain it in order to coordinate their actions. And so in this case, it goes up, it looks for the navigator, the outline window, and that outline window will be able to give it the reflection object that it can use. So we did that, and so now we should be able to go back to this guy and refresh it, and now we have the browse me element here, which expands into a browser on this very thing. And so now we can change it in itself. So we can open the definition here, and there's our code. And sort of as a final thing, just to illustrate, let's change actually another combinator. So instead of this heading details thing, which allows you to expand something to show details, we'll replace it with something that in the collapsed state shows an inspector, and in the expanded state shows the browser file. And because now we are in the same thing, we don't even have to go anywhere, we just click refresh, and so now we have an inspector here, and when we expand it, it replaces itself with the browser. And it's all on the very same thing that we're looking at. So, to sort of summarize. So what you have just seen, we all know programming in the debugger, and in VisualWorks you can program in the inspector. But here you see it's programming wherever you want. You can combine tools however you like, and all this because the approach is different. So instead of the concept of a tool as something that is aware of the structure of the domain and basically replicates that structure in the structure of its window, we have these composable entities, presenters that we compose whichever way we like, and they
They also mirror the structure of the domain, but they mirror it in a flexible way because they nest arbitrarily deeply, and each of them can have the structure that is the most appropriate for the thing that it represents. So this is just about it. So I want to say thanks to my teammates and other people at Cadence, and also to you for being the audience of this very first public demo of this stuff. So questions? We won't be able to do a lot. So crystal clear. So that's good.
We're in CDs.
What, with the way that you speak is different than Smalltalk, has that influenced or gotten you thinking anything different regarding version control?
Well, this isn't really a UI question. Well, I'm not the one to answer this question really, because version control, well, my view of version control is the same as my view of, let's say, car engines. I wanted to work on a turnkey, so, no. Okay, well, thank you.
Hey, you. Hold on. So at one point you had a block of code in the last example that you did, and I noticed that it had two arrows, one for the return of the method and one for the return of the block. And I was wondering if I just missed something that is particular about Newspeak, and it's just me not being very familiar with it, and if there's some detail there that I should pay more attention to in reflection.
Yeah, it is a return from the block. So it is a return from, it is a normal return, because this is what I want to do. But no, this isn't anything Newspeak specific.
Oh, okay.
I will do the same in Smalltalk code in the same situation.